Hello everyone. So today I'm going to teach you how to create this game. It's like a Pong but with elements of football. So I don't know, you can call it soccer Pong or something like that. And here I'm using plain vanilla JavaScript and HTML and CSS. I'm not using any libraries. Created this game about 2 years ago when I finished the discipline on computer graphics during my major. And basically you control the left character, and this one is like an artificial intelligence which is following more or less the movements of the ball with some random movements too. So to render to render each frame, we are basically using this method here, which is native to most JavaScript engines, and basically this method tells the browser that you wish to perform an animation and requests that the browser calls specified function to update an animation right before the next repaint. So let's see how this works in practice. Without further ado, I will just start coding. I will create a directory. We'll call it soccer Pong. Let's access this folder and let's execute Visual Studio Code. Let's create an HTML file. Okay, our canvas where we are going to have our game happening is going to be an SVG container, and this rectangle, the ball, they are SVG elements inside that container, and we are going to use JavaScript to manipulate these elements. So first we need to create an SVG element, and we need to specify a width and height. I want this game to be played also on mobile, so let's choose a width that even the smaller mobile phone should support. So 320 pixels should be good, and a height of 560. So we will have a rectangle, and instead of having a horizontal rectangle as I have here, I want it to be a vertical rectangle. So that's why the height is bigger than the width. Okay, we have our SVG container, and we need a circle, which is our ball. So you can use a circle SVG element. In a circle, you must specify 4 things: the coordinates of the center of the ball, the X coordinate, the Y coordinate, and you need to specify the radius. So it's three things actually. And we want the circle to be exactly at the beginning of the game, exactly at the middle of this container. So to find the X coordinate of the middle of the container, we just need to divide the width by 2. So we are going to say the coordinate X of the center of the circle is 160, and the same reasoning applies to the Y coordinate, which is half of 560, which is 280. And then we need to specify a radius, and let's say a radius of 20 pixels. I also want to fill this with the color white, at least for now. Let's give this container a background. So let's create a tag styles. We should create it inside the head, if I'm not mistaken. Here. So I'll give this an ID of canvas, and the circle will also have an ID of circle. No, let's call it ball, because it's a ball game, right? And let's reset our styles. So first margin 0, padding 0, and also I want to do this. Okay, let's style our canvas. So let's give it a background color. I don't know, this time I want to use like purple but darker. Yeah, this is good. We'll save it. Let's copy the path. Let's open it. Here, as you can see, we have our arena where the game is going to be played. We have the ball. And okay, that looks good. I just want to center this container. So to do that, let's give a background color to our body, and let's use flex to center everything. Item center, justify content center. Okay, now it's in the center. I wanted this also to be centered vertically, but for now let's not worry about this. Okay, we have our container, we have our ball. Now we need to start animating this. And the first thing, well, we need to know the basics about computer graphics 2D animations. And one thing you need to know is that in 2D you have, oh, this doesn't look good. You have the upper left corner, which is the coordinate 0, 0. And as you go further to the right, the x coordinate will increase. So for instance, here it could be 10, and the y coordinate is 0. When you go down, the y coordinate increases. So here it could be 0, 10, for instance. Oh, I'm suffering to draw with the mouse. And as you go further to the right, the x coordinate also increases, so this will be 10, 10. This is important to know because, for instance, our ball, it will have a velocity, a speed, an horizontal speed, that is how fast it moves each frame horizontally, and a vertical speed, how fast it moves vertically each frame. This speed is in pixels, so it will move 5 pixels horizontally per frame or 5 pixels vertically per frame, something like that. So when you have the horizontal velocity Vx, when Vx is positive, then you are going in that direction. But if Vx is negative, then you are moving on the left direction. And when Vy is positive, you are going down. And when Vy is negative, then you are going up. So this is the basic you need to know. Sorry for my ugly drawings, but I think you got the point. Alright. One thing we need to do is to create a model. A model is where the information about our objects in our animation is stored. So For instance, we have the current position of the ball, and that is just a series of coordinates, in this case just two coordinates, cx and cy, and that will be stored in our model. And whenever we need to, when the ball moves, we are going to update this model with new information. So let's create a JavaScript object, and let's create inside the model another object, which is our ball, and it has the properties of our SVG circle here. So cx initially is 160, cy is 280. We have our radius is 20. And we also need the velocity, right? The horizontal velocity. Let's say for now it's 5. The vertical velocity is 5. Okay, we have our model, and now we need our update function. So let's create a function, call it update, and this function will be called each time we want to update our model, or so it will be called each frame. And what we are going to update? We are going to update the ball coordinates, right? Because the ball is moving. So we are going to get our ball, and we are going to update the cx coordinate, and this will be the previous coordinate plus the velocity, so the horizontal velocity. And you could write it like this, but it's more concise if you just do plus equals. Let's do the same for the vertical movement. So the vertical coordinate of the center of the ball will increase the corresponding to the velocity, the vertical speed, each frame. Basically, this is how many pixels the ball is going to move per frame. Now that we have our update function, we need our render function. And what does the render function do? Basically, it will directly manipulate the SVG elements. So we need to first grab the elements. In this case, we want to grab the ball. Let's say our ball element. It's the element with the ID of ball. We defined this ID here. And then we can create our function. We'll just move this up here. It looks better. I will create my render function. And basically, I want to set the newest position. I want to set the attributes of the ball with the values that are present in my model. So I will call ball element. I'll say set attribute, and the attribute is cx, and it will receive the value that is stored in my model. Cx, and I will do the same for the vertical coordinates. Cy. And now we need to animate it. So how can we do that? We are going to do using this function that I told you about earlier. Here there is an example of how it works. Basically, you need to define a step, which is basically what happens each frame, before each frame is rendered. And this step function is a callback function. It will call request animation frame recursively and passing itself as an argument. So I know it sounds complicated, but it's not. So let's create our step function. I will say const step equals an arrow function, and here I want to do two things. I want to update our model, and then I want to render first, because I have my initial values here. So I have those values. I want to render them, and then I will update it. And the next time the request animation frame is called, it will render with the previous updated values and then update the values again. So let's call render. Let's call update. And then we call request animation frame, and we pass step as the argument. Okay, now what else? We need a main function. And in this main function, we are going to call request animation frame for the first time, and then this will call itself recursively over and over again. Now I need to call main, execute our main function here at the end. Okay, this should be enough to make the ball move. Let's save it. Let's update it. And as you can see, the ball is now moving, but it's moving out of our container. So what are we going to do for the ball to bounce as it is supposed to? Basically, we need to create some if statements. If the ball reaches this limit, we are going to invert its velocity. So we are going to do that in our update function. How can we do that? It's very easy actually. So let's start with our start with the top wall. The top wall is when our y coordinates is 0, right? As I explained here, when the I coordinates is 0, this is the top wall, and we want the ball to bounce it. So basically we need to say, if our model ball cy is less or equal than 0. That means if the ball reaches the upper wall, we need to invert its vertical speed. We are going to say model ball vy is equal to math.abs. I want the absolute value of the current velocity, and this is always going to be positive, right? So when the y velocity is positive, the ball will move down, it will go down. This way we are making sure the ball is moving. When it hits the wall, it's going to bounce and it's going to move down. But there is a problem here, because we are specifying the coordinates of the center of the ball, and we actually want the coordinates of the extremities of the ball, the surface of the ball, right? So how can we do that? Well, we can just subtract the radius. So let's model ball r, and when this is less or equal to 0, then we are going to invert its vertical velocity. Now the same reasoning applies to the other walls. If you got this, you can use logic to create the if statements for the other walls. So top wall, right wall, just copy and paste. Now we are concerned with the horizontal coordinates and horizontal movement. And when this plus the radius is greater or equal to the maximum width, which is 320, that's our right wall. And the left wall. Oh, here we need to invert the horizontal velocity, right? And when the ball is moving to the right, you have a positive velocity. So Vx is positive. Oh, I just closed the file. Fuck. So when the ball is moving right, Vx is positive. When the ball is moving left, Vx is negative. In this case, the ball hits right wall, and we want the ball to bounce and to go left instead. So we want the velocity to be negative. Here we are getting the absolute value, and we need to put a minus in front of it. So we are going to make Vx negative, so the ball will move to the left. Okay, this looks good. Now let's go to the bottom wall. Here we are dealing with the y coordinates, and yeah, we should add the radius, and when the radius plus the center of the ball is greater or equal than the maximum height, which is 560, we want the Vy to be, we want it to be negative, because when Vy is negative, then the ball is moving up. When Vy is positive, the ball is moving down. Okay, we have top wall, right wall, bottom wall, no, left wall. Let's just copy this, and we need to subtract the radius here, and when that is less or equal to 0, we want our velocity to be positive so that it goes right. Okay, that should be enough to make the ball bounce on the walls. Let's save it. Now let's update. Yes, it works as it was supposed to, and now the ball is bouncing. So there are a few things we need to do now. Like, you can notice that always when the game starts, the ball moves in the same direction. It moves to the bottom right corner, and we don't want that. We want it to move in different directions. So what we need to do is to create a function, a randomized function that will make the initial velocity to be random. So let's see how we can do that. So we are going to use math.random to generate a random number, and we are going to use that to make the sign of our velocity random. That is, if our velocity is initially positive or negative, both the horizontal and vertical velocity, that should be random, so that the ball goes to a random direction when the game starts. And here we have an example of a function that, given a maximum, it will return a number between 0 and max excluding the max itself. So get random int of 3 returns 0, 1 or 2. We are going to use that logic to create a function that returns either 1 or -1. So let's call it random sign, and it takes a number n. Here we have a random number that should be either 0 or 1, like the flip of a coin. And for that we need to put the max here, which is 2. So that random number will be either 0 or 1. So if random number, that is if random number is 1, we are going to return a positive velocity, a positive n. Else we are going to return a negative n. And that's all we need to do. Sometimes I like to put some space between things, don't know. Anyway, now we have this function random sign, and all we need to do is to alter our model so that our initial velocity has a random sign. It's random sign. Now if we save this and we go to our soccer Pong, you can see every time it goes to a random direction. Now that we have our ball moving and bouncing as it is supposed to do, we need to have our players here, and they are going to be rectangles. So let's see how we create an SVG rectangle. If you look at the docs, you need to specify the x coordinate, the width, the height. Can you specify also the y coordinate? Yes. Okay, so let's go to our SVG container here. To create a rect. So the player that we are going to control, I want it to be on the bottom of the screen, and then we know that that is equal to having a y coordinate of the maximum height, which is 560. And let's just, I think this is for the top left corner. So let's say, let's move it 20 pixels up, and I want the x coordinate to be the half. And let's subtract 40 from this value, so 120. Let's also fill this with white just for now. Let's give it a width of 80, a height of 20. Let's see how this looks. Yeah, I think that's good enough. If you notice that the ball is too big comparing to this player here, so I guess we should diminish the radius of the ball. Instead of 20, let's make 15. Let's see how this looks. Okay, that looks good. Alright, now that we have our player here, we need to add it to our model so that we have our current state of the position of the player always tracked, and that information is always stored in our model. So let's say player 1, and let's give it the initial values as it is right here, as it is defined here. So with height and the coordinates, okay. But the player will be moving, right? It's going to move either to the right or the left. So we need a horizontal velocity. We need Vx for the player. So let's say Vx, and initially Vx is 0. Let me think. Okay. Now we need to also create the logic for the movement of this player, and that will be done here in the update function. We need to render our player according to the values stored in our model, and on our main function we also need to add some event listeners so that we can listen to the event of pressing keys on the keyboard, so that we can move our player accordingly. Where should we start first? Let's first create our event listener. So we say document .add event listener. And the event is key down, and that takes a callback. Just take as parameter our event. So here we need to have a switch, and depending on the key that is pressed, we want to change the velocity of the player. So let's say if the key pressed is A, or if the key pressed is uppercase A, we want the player to move left. That means the velocity of the player 1, that's how I call it, right? Yes. Vx needs to be negative. Let's say -3. And it's a break. Now let's go to the other case. If the player press D, or the uppercase, the velocity is going to be +3. So it's going to the right. And in case none of these keys are pressed, then our velocity is going to be 0. And just to test this, we can now console log a.key. Let's save. Let's open the developer tools, and now you can see that this works. Okay. So now that we are updating our model as we are giving commands to the player one, there is only one thing left to do, which is render our player one accordingly to the model. So let's create let player one element. We need to give an ID to our player one rectangle. So ID player one. And now we need to set attributes the same way we are doing here. So player one element, set attribute, and the only attribute we are changing is the VX, right? No, we are changing also the coordinates. So we don't need to set the VX here because we are doing that on our event listener. We just need to have our coordinates, our CX coordinates, the horizontal coordinates. It's not CX, it's just X, sorry. CX is for circles. In this case, a rectangle is just the X coordinate. Model, player one. Okay, should be enough. And now we need to write the logic for the movement in our update function. And let's write it down here. Player one x plus equal the velocity of the player. Alright, that should be enough to move it. And yeah, we now have our player moving, but there is this issue. We didn't specify limits for the movement of the player, so it goes beyond the container. So we just need to write some if statements here. Let's organize this. So this is the bow logic. Okay. This is the player one logic. And here I need to write an if statement that we are only going to do this if model player one x plus the velocity, if the result of this doesn't exceed the limits of our container. So let's create a variable, call it next player one position. That's too long, but it's explaining well what this is. If next player one position is bigger than the limits, the limits of the container, which is 320 pixels. If that, where is our if? If that is bigger than 320, or if next player one position is less than 0, and we want to update in case. So instead of an or, I'm going to say we're only going to update the position if this condition here is true. That is, if the next position of the player is inside the limits of the container. And then we are going to update its position. Okay, that should work. Let's save it. And now it's not working. Well, the left side is working. Oh, I see why this is not working. Because the x coordinate specifies the top left corner. So you can see that when this corner here reaches the limit, it will stop here. And so I need to add the width to the width of the rectangle. The width of the rectangle is 80 pixels. We need to add that to the next player 1 position. So this plus 80 should be less than 320. Let's see now. Yep. So now we can't move beyond the limits of the container. Okay, now what else we need to do? We need to create our second player, which will be automated, so it's going to follow the movement of the ball with some randomness in a way that it's not like an impossible player to beat. And we also need to make the ball to bounce on the player itself, because right now it's going through the player and we want it to bounce on the player. Before we start coding the logic of the bouncing movement of the ball on the player, we need to consider those 4 possibilities. So in this first possibility, the horizontal velocity of the ball is positive, so the ball is moving from left to right, and it's the same for our player. The player is moving from left to right, and in this case the result of this in a real scenario is that when the ball hits the player, when it hits this rectangle, it will rotate, and it will rotate in a counterclockwise direction. So when that happens, the result will be that the ball will have a resulting vertical velocity that is negative. So let's write this down here. When, let's say Vx P for Vx player, so let's say Vx player is positive and Vx ball is positive, Vx result is negative. Now let's consider this other case when the Vx of the ball is negative because it's moving to the left, and the Vx of our player is positive. And in this case, the result of the bouncing movement will be a ball that is moving towards the left, that is a ball with a resulting velocity that is negative. So in this case, let me just copy this. Vx of the player is positive, Vx of the ball is negative, and Vx result is negative. Now in this case, our player has a negative velocity. In both of those cases here in the right, our player has a negative velocity, and our ball has a positive velocity, and here a negative velocity. So In this case, the ball will rotate clockwise when it hits the player. And in that case, let me think. In that case, the ball will bounce in this direction. And in this case, the ball will bounce in this direction. So let's write the conditions again. When Vx player is negative and Vx ball is positive, Vx result is positive, and here if X player is negative, the Vx ball is negative, and the horizontal velocity of the resulting movement is positive. So let's see if we can extract some logic from these four cases. Here we have two cases that the horizontal velocity of the resulting movement is positive, right? And here the resulting velocity is negative. So perhaps instead of writing this complex logic, we can simplify this even further, right? So I want to erase this. We can conclude that when the Vx player is positive, our Vx result is always negative. So if Vx player is positive, then Vx result is negative. And if Vx player is negative, the Vx result is positive. So from this analysis we concluded that it's not really relevant, the Vx of the ball. So we just need to know the Vx of the player to know what is the resulting direction that the ball will follow after hitting the player. So this is the conditions that we need to write in our code. After the logic of hitting the walls, I want to write the logic of hitting the player. So ball hits player 1. And when that happens, so we need to write an if statement. And we are going to say if model the position of the ball, so the vertical position cy plus the radius because we want the bottom extremity of the ball plus the radius, if that is greater or equal to the vertical position of the player, which is this. So model player 1 y Okay, and we also need to know if the ball is on the same horizontal position as the player. So ball CX, we need to consider, let me think. We just need the CX. So if the CX is bigger or equal to model player 1, I forgot the quotes here. And model I'll move this to another line. Now I'm checking the right limit, so I need to add the x coordinate of the player 1. I need to add its width. In this case the width is 80, but we have that in our model, so model player 1 width. Okay, I think that should work. So if we enter this condition, it means the ball is hitting the player 1. And then what we need to do inside this if statement, basically we need to write those two if statements. So if model player 1 Vx is bigger than 0, else if and we also have the condition when the velocity is 0, so that's going to be or else. So when the velocity of the player is positive, the resulting velocity of the ball will be negative. So we just need to copy this instruction right here. This is making the currently horizontal velocity of the ball to be a negative value. And if the velocity of the player is less than 0, then the resulting velocity is positive. So we are getting the absolute value of the velocity, that is a positive value. Else, in the case the player is not moving, the resulting velocity will be, nothing will happen actually. The resulting velocity, horizontal velocity, will remain the same. So actually we don't need this else statement here, because we just need to think that if the player, let me copy here, if the player is stopped and the ball is moving with a positive horizontal velocity, this means it's positive, right? The ball will bounce and go to the right. And if the player is not moving and the ball comes from the right with a negative horizontal velocity, then the resulting movement is that the ball will go to the left, that means it will remain with a negative horizontal velocity. Okay, so in that case nothing happens. We don't need to write any code for this. And let's save. Let me copy the path here. Okay, now I need to try to hit the ball to see if that works. I guess it works. No, it doesn't really work. Okay, so we were just thinking about the horizontal velocity, but we forgot about the vertical velocity. And what happens when the ball hits player 1 is that the horizontal velocity will invert, right? And all we need to do is the same as we do when it hits a wall, in this case a bottom wall. So this will make the ball to go up. Let's save it, let's refresh, and yeah, now we are managing to make the ball hit the player and it will bounce back. Okay, now we want to create our player 2, which will have an algorithm that will make it move automatically, following more or less the movement of the ball. And we want the bottom wall to be actually, the ball can pass through it, and when the ball passes, it's a point. So let's move on to this next step. I just realized that I committed a mistake. So this is working fine when the player is moving, but you will notice that if the player is stopped, I need to just, when the player is not moving, then the ball will pass through it. And the problem is that there is this case here when Vx of the player 1 is equal to 0, and in that case we are not inverting our Vy. So if we are doing this inside this if and inside this if, and we also want to do it in case the ball hits player 1 and the player 1 is currently stopped. So let's just have this instruction here. Let's take it out of here, because in any case when the ball hits player 1, it is going to go up, it's going to bounce up. So now we save it, and now I want the ball to hit when the player is stopped. Yeah, and now it's working as it was supposed to. Let's create our player 2. Alright, so here we are going to create a rectangle just like this one. Let's just copy. The ID is player 2, and the top left corner, in this case the x coordinate is the same, but the y coordinate is 0. Let's save and see. Yeah, this is where the player 2 should be. And this player 2 is going to move, it's going to follow the movement of the ball, so its movement is going to be automated. So we need to create our player 2 also in our model. Let's create our logic. our movement logic for the player 2. Here in our add event listener, we can see that the horizontal velocity of the player 1 is either -3 or +3. And what we are going to do here in our update function is to say if model ball Vx is positive, then player 2 Vx is going to be 3. Else, if the horizontal velocity of the ball is negative, then the velocity of the player 2 is going to be -3. So this will make so that the player 2 is following the movement of the ball. And now we need to declare our player 2 element. And now we can render it according to the model. So player 2 element, set attribute x, okay, and we just forgot to update the player 2 position. So this is player 2 logic, and then we also need to do the same thing here to make sure the player 2 will not exceed the limits of the container. So we know the next position of the player 2. Okay, I guess that should work. And now, as you can see, the player 2 is always following the ball, right? And it is actually pretty good, because so it's going to be very difficult to beat this player, because he's always following the movement of the ball in a perfect way. So this player doesn't ever commit mistakes. So this game is not going to be fun to play, but we can add some randomness to the movement of this player. So the same way we use randomness here, this is the instruction that is making the player 2 to move. It's updating its position. And we are going to just flip a coin here, and we are going to update the position only with a certain chance. Like, so let's declare a random number between 0, I don't know, 0 and 9. So we can say, like, we want the player to move with a 40% chance, perhaps, or 60%. So if random number, let's say less than 6, because this is going to random number. In this case, it's from 0 to 9. If it's less than 6, then we are going to update its position. And now we save. As you can see, it's not a perfect player anymore, because the movements, his movements are limited by this randomness. Okay, so that should make the game a bit easier to play. And now what is left for us to do is to make the ball to go through the top wall and the bottom wall. And when that happens, we are going to increment a counter, which is the points. So if the bottom goes through the upper wall, it's a point for the player 1. And if the ball goes through, if it passes through the bottom wall, then it's a point for player 2. We also need to write the logic for the situation when the ball hits the player 2. The player 2 is this one. So ball hits player 2. Let's just copy and paste and change this code. So when the ball minus the radius is in this case, we need to add the height of the player 2 here, plus model player 2 height. Because this is the top left corner, we need to add the height, so we get the inferior limit of the player 2 of the rectangle, and the radius cannot be less or equal than the inferior limit of the rectangle. And this is the same as it was for the player 1. So if the player 2 Vx is bigger than 0, in this case I don't remember if I need to invert it or not. Let's just make it this way and see what happens. Okay, I guess that should work. Let's see. Our player 2 is having trouble to reach the ball, so let's give it a bit more chance to hit it. Let's say if random number is less than 8, it will increases its chances. Well, something is definitely not right. Oh, here we should have a positive value for the ball to bounce. Okay, now I think it's working. Let's give it a bit more chance to hit the ball. But less than 9. Now we need to modify our code so that every time the ball reaches this condition or this condition, we are going to make a point. So let's create a div here, and let's create a span for with the counters to track the points in the game. And let's say id player 1 counter player 2 counter counters. Let's give it a font size of large. Let's see how this looks. For our counters to appear at the center of the container as we want, what we need to do is set our counters with an absolute position, and then the top will be the margin top of the canvas, which is 50 pixels that we have here, plus half of the width, half of the height of this container. So half of the height, this case 560, that's 255, if I'm not mistaken. So 255 plus 50, that's 305 pixels. And now it's exactly at the center. Yes. And now every time that the ball passes through the upper wall or the bottom wall, I want to update this corner and I want to reset the game. So how can we do that? Basically, we already have these if statements here, so we are going to add some logic inside this case of the top wall and the bottom wall. So we need to create another two variables in our model: counter player 1 and counter player 2. And then when this happens, let's update our model. Model counter player. Okay, on the top wall, it's the player 1 that is making a point. So counter player 1. We are going to increment this. And in this case, we are going to increment the counter player 2. And also, we want to reset our model to the initial values. So in the position of the ball, we want to reset it to the initial values. So we are going to create another function here, call it reset game, and basically we are going to reset the position of the ball with these values. So model ball cx is equal to 160. Model ball cy 280. The radius doesn't change, and the vx and vy are going to be random sign of 5. This is going to reset the game. Reset game. Bottom wall, reset game. And on our render function, well, we need to select the player 1 counter and the player 2 counter. So we are selecting these elements because we want to update their values on our render function. So we are going to say player 1 counter element font for the inner, well, we can use inner HTML is equal to player 1 counter. We are going to do the same for the player 2. Now let's see. Oh, it starts as undefined. Player 1 counter. Let's look at our model. Oh, it's counter player 1. So counter player 1, counter player 2, player 1 counter. Okay, everything seems right. Okay, 1 0, 1 1, 2 1, 3 1. And we have our Pong game. So we can, of course, improve this. For instance, you can see that the game is starting too fast. And we can solve this by adding some more pixels to our conditions of point. So instead of saying less than 0, let's say less than -20. And here, instead of bigger or equal to 560, let's say 580. So that will give a bit more time until the game is resetted. Let's see. Yep, but we could make it, give it a bigger delay. Let's see. Okay, I think that's acceptable. So I'm leaving the code available in the description of this video, and I hope you learned something. This is a very fun coding exercise. It helps us to understand the basics about 2D animations, and it's a good logic exercise. So I highly recommend that you try to create your own games with this structure of having a model here as having a model and having a render function and an update function. You can apply this concept to other games, and you can create any kinds of animations applying the same methods that I'm using here. And that's it. I hope you liked it, and if you learned something, like the video and subscribe. Thank you.